Welcome to ERC Tipsnology. In this video, we will be learning about series parallel circuits ladder network. So let's start by drawing our circuit. Let's put here 6 resistors connected in series parallel. And let's put a voltage source of 12 volts, resistors of 1K, 2.2K, 3.3K, 6.8K, 10K, and 22 kilo ohms resistors. We'll be finding out all the voltages V1 up to V6 and all currents I1 up to I6. And we will also calculate for all the powers dissipated by the resistors, and of course we will calculate the conductances, and finally we have here also the total current. Now let's start by calculating the total resistance. The total resistance can be calculated first by getting the R56 by adding them, and then we'll get R456, which is the parallel of R4 and R56. So we will multiply the two resistors, R4 and R56, and add them. Divide the product over the sum. And then after that, we will be calculating the R3456, which is actually the series of R3 and R456. So the series of R3 and R456, we will add them. After that, we will get the parallel of R2 parallel to R3456. So the R2 is parallel to R3456. So we will get the product of the two resistors R2, R3456 divided by the sum of the two. And of course, after getting R23456, that would be series with R1. And so we can get the R total equal to the series of R1 plus R23456. Now what's the value of R1? It's 1 kilo ohms plus R23456. But we have to get first the R5 and 6, so that's equal to 10 kilo ohms plus 22 kilo ohms. We got 32 kilo ohms, and we will calculate R456, and we will get 6.8 kilo ohms over or multiply to 32 kilo ohms over the sum. Now when you multiply kilo ohms by kilo ohms, that would be kilo ohms squared. So we will cancel that later on when we divide it by kilo ohms. Now let's get the answer of this R456. So we will be getting 217.6 kilo ohms squared, because we multiply kilo ohms by another kilo ohms, over the sum of 6.8 and 32, and then we'll cancel one of the kilo ohms there, and the single kilo ohms will be left. So the unit would be kilo ohms for our answer. And so the answer is 5.60824 kilo ohms, or 5.61 kilo ohms for our R456. Then we have to calculate the R3456. We will be getting 3.3 kilo ohms plus 5.61 kilo ohms for our R3456, which is in series, and we will get 8.91 kilo ohms. And then we will calculate for R2 parallel to R3456, so we will multiply 2.2 kilo ohms, the value of R2, with 8.91, which is R3456, and divide it by the sum of the two resistors. And we will get the product over the sum of the two resistors that we calculated. We got 13.6 kilo ohms squared, and we will divide it by the sum, which is 11.11 kilo ohms. Cancel one of the kilo ohms there, and we will get a final answer also of kilo ohms. And so our final answer there will be 1.76436 kilo ohms, or let's round it to 1.76 kilo ohms. Now finally we get the R total, and we will add 1.76 with 1, we will get 2.76 kilo ohms. That's the first step. We have to find the total resistor or total resistance carefully. Now we can get the total current by Ohm's law, Vs divided by RT. Now when you divide volt, divide it by kilo ohms, the answer would be milliamperes. Don't forget that. When you divide volt by kilo ohm, the answer will be milliampere. Volt over kilo ohms will be milliampere. And then let's round this 4.347 to 4.35. That's it for the total current. And the next step, number 3, is we will find the value of our I1, and it's exactly equal to I total because they are in series. The R1 and the Vs is in series, so I1 equals IT, 4.35 milliamperes. So the I1 is also equal to IT but not equal to I2. So to get the next current, if we want I2, for example, let's try to do first the I2. You can use the Ohm's law, V2 over R2, but we have a problem because we don't know V2. But if we know V3, 4, 5, 6, that will also be V2. Or we can get the V2, 3, 4, 5, 6. Because V2, 3, 4, 5, 6 is also V3, 4, 5, 6, and it's also V2. So what we'll do here is we will first try to figure out what will be the value of V2, 3, 4, 5, 6, which we can calculate it by using the voltage divider rule. R 2, 3, 4, 5, 6 divided by the R total multiply with our Vs. Now the value of the R3, 4, 5, 6 has been calculated before, and it's equal to 1.76, and we will kilo ohms, and we will divide it with the value of the R total multiply with the value of our Vs. So the R2, 3, 4, 5, 6 is 1.76 multiply with 12 volts over the R total of 2.76. We would get the value of 7.65 2173913 volts, and let's round it to 7.65 volts. So that would be the V2356, also V2, also V3456. And when you divide volt by kilo ohms, we will get volts divided by kilo ohms, we will get milliamperes. And our answer here for I2 will be 3.47727, or let's round it to 3.48. 3.477, we can write here 3.477 milliamperes. Now for the next step that we will do is let's analyze that the I3 can be calculated by Kirchhoff's current law, or KCL. We can subtract the value of I1 minus I2, and we would get the value of I3. Now I1 here is equal to IT, which is 4.35 milliamperes, minus the value of our I2, which is 3.477 milliamperes, And we will have here the answer of, let's subtract. We got the value of 0.873 milliamperes. Now for step number 7, we will be calculating the value of I4. Now I4 here, and this one is I5 going out from that point, we will have I4. We can use the other formula, which is Ohm's law. So we need to find V4 over R4. But we have a problem because we don't still know what is V4. So V4 is actually the voltage across the R4. And what we'll do here is we will get the V4 by making it equal to V56. And it's also equal to the whole parallel V456. So V4 equals V56 equals V456. That's what I mean. Because this is one of the property of a parallel connection. So I456 by Ohm's law, I456 multiply with R456, we will get V456, and that's also V4. Now I456 is also equal to I3. So if you multiply I3, which is 0.873 milliamperes, multiply with R456, the R456 has been calculated before, it's 5.61 kilo ohms, then we will be getting the value of V4. But milliamperes multiply with kilo ohms, don't forget, is equal to volt. Now, the answer for the multiplication of the two numbers would be 4.89753 volts. And there you go. We got the V4. We can round it to 4.900 or 4.90 volts. So we got V4 equals to 4.90 volts. Now we got the value of V4. We divide it with R4. We will have now the value of I4, but don't forget, volt over kilo ohms equals milliamperes. And so let's calculate for the final answer here. It would be 0.7205, and let's round this one, 9 milliamperes. Now we have I4 and I5. We will get the value now of I5. That's equal to I3 minus I4 by Kirchhoff's current law. Now, how much is our I3? It's 0.873 milliamperes, right? So the I3 is 0.873 milliamperes minus the I4 of 0.72059 milliamperes. So let's write it down over here. Let's write the value of I3 minus the value of I4, and let's use the calculator to subtract them. Let's see what will be the answer. 0.15241 milliamperes. Now we got 5 currents, and the last current, which is I6, is equal only with I5 because they are in series. The R5 and R6 is in series, so I5 equals I6. And we already know I5, so we will just make it equal to I5. I6 equals I5, and there you go. We got 0.15241 milliamperes. And I1 is equal to now here's our answer. I1, I2, I3, I4, we got the I4. Let's just summarize. And then we have I5, and we also have I6. Now that we got all of the currents, it's so easy now to calculate for the voltages across its resistors by simply using the Ohm's law. So let's write the formula for Ohm's law for V1. V1 is equal to I1 multiplied with R1. And we know the value of I1, we know the value of R1, and so we will get the value of V1. By the way, milliamperes multiplied with kilo ohms will be volt. Milliamperes multiplied with kilo ohms will become volt. And so we can continue calculating for the other voltages. V2, we will get V3 with the same or in the same way where we are using Ohm's law. Current multiply with the resistance. And we also have V4, we have I4 multiply with R4. We have V5, I5 multiply with R5. And lastly or finally, we will get V5 equals I5 or V6 equals I6 multiply with R6. And all of the values of the currents has been or have been calculated. So, and the R's or the resistors are also given. Now let's do the power dissipated by each resistors. It's so easy also. You just multiply the voltage with the current. So we can use this one of the formulas in power. Voltage multiplied to current or VI. And we already know all of the values of V or voltages. We can use that and we can multiply it with the currents of each resistor. So the voltages across each resistors multiply with the currents through each resistors. We will get all the powers dissipated by all of the resistors. And just calculate them, multiply them, and we will get the answer of milliwatts because we are multiplying volt multiply with milliampere. The answer will be milliwatt. Again, V multiply with MA, we will get MW or milliwatts. And there you go, we have calculated all of the powers including the P total, Vs multiplied with IT. And the remaining calculations that we will do will be for the conductance, which is just the reciprocal of the resistors. So if we want to get all the G, all the conductances, we just divide 1 over the value of each resistors, including the G total. We can get it by dividing 1 by RT. And if you divide 1 by kilo ohm, the answer would be millisiemens, or small letter M and big letter S, that's millisiemens. So thank you for watching our video. I hope that you will subscribe and support our YouTube channel, ERC Tipsnology. Before we end this video, I hope you will subscribe and support us. Now, just to have a quick summary of what we have done, which rules we have used. Again, we used first the Ohm's law. We also used the formula for power. And we used the Ohm's law again for the calculation of the I total, V over R. And we used the rule in series where there's only one current. That's why we got I1 equals to IT, because the R1 is in series with the Vs. And here we use here Ohm's law. And then we used here the voltage divider rule when we calculated for the V23456, which is equal to V2, which is also equal to V3456. This is following the rule of Kirchhoff's current law. And this one we used Ohm's law. Here we followed the rule for parallel. The V4 equals V56. And it's also equal to V456. That's the rule for the parallel. We used that rule. And then here we used again the KCL or Kirchhoff's current law or we also say it as Kirchhoff's current law. And here is the rule for series again, because R5 and R6 are in series. So the currents I6 and I5 are equal. Going back here, this is also Ohm's law. And the last calculation we have done is just the reciprocal of the resistors, and that's for the conductance. Now for the power, before we end, remember we can also use another formula, V squared over R, or we can use I squared multiply with R. But we have chosen to use P equals VI. So there you go. Thanks again for watching our video. I hope that you will support our channel, share this YouTube video, and have a nice day, everyone.